Hello, everyone. Thank you so much for joining us this afternoon. I'd like to kick off and kind of do a bit of a state of play, I think, for the manufacturing industry, just to sort of set the stage. And so, Kevin, I know a couple of years ago, you said that we have now, quote, entered the 4D age of fully digitized design, manufacturing, assembly as a service. And I'm curious to hear from you and you, Olu, as well. What is the biggest change in the way that defense manufacturing works in 2025 versus maybe 5 to 10 years ago? I guess just briefly would love to hear from you both. Kevin, you want to start?
Sure, thanks, Ann. Well, I don't know what it was 5 years ago, honestly, because I started Divergent about 10 years ago, and it was started because I saw that the West had offshored its industrial base, and you had a bunch of different technologies, whether they were machine learning, different software point solutions to try to make factories more efficient, or 3D printing, or robotics. And in my technology life, I've never seen any of those things, when it's a single technology, be any breakthrough. And when it's applied to an existing architecture, it's kind of an anti-breakthrough. You need to take those technologies and combine them in a totally new system. So we took that clean sheet approach and have a system now that is TRL9, fully commercialized in automotive as about 3 years ago. And that system was designed as a full integrated system to fully engineer in an automated way a structure using machine learning, concurrently run the digital twin of our manufacturing process and our assembly process, both of which are toolless and fixtureless. So it's a design agnostic set of printing and assembly equipment, and then generate that design in tens of hours rather than months or years. And then on production equipment with production processes, print it at an industrial rate and assemble it, because the assembly features are not in the equipment but built into the structure itself. 2.5 years ago, General Atomics reached out to us, and I learned for the first time about affordable mass, and they said, how are you going to, could you apply what you're doing in automotive to something like a Suez drone, like a small unmanned aerial system? And so within about 2 months, we had taken Suez drone, the program called Eaglet. We had reduced the number of parts by 98%. We reduced the number of parts through functional integration from 184 parts to 4 parts. We reduced the development cycle time by about 95%. We reduced the development cost by 50%. We reduced the variable cost by 40% against traditional casting and stamping and carbon fiber layup, and we took out 5% of the mass. In turn, I'd say General Atomics put out a magazine article saying what we had done, and over the last 2 years, we've gotten in over 20 contracted programs with almost all of the major US primes. And I'd say this is now a system that, respectfully, I think, people in Europe and in NATO need to learn about and learn about how it could be right-sized to almost any country in NATO, and could really act as something that not only de-risks their production, but leapfrogs other production systems, and allows for a great deal of innovation, because you'd no longer have the capital barrier. It's kind of like a fully digital distributed Foxconn, except for the West.
I'm curious, how fast could you build a missile right now, for example, using the technology?
I'd say on something like a extended range assault missile that, say, has about 30 kilograms of printed mass for the fuselage structure and wings and empennage, we're printing, depending on the structure, at about 2 to 3 kilograms an hour. So if we have 10 printers running, that's an hour of print time across 10 printers. So each of those printers, actually on that structure, the structure gets split and packed, all of that is automated. So when the structure is being optimized, it's also optimizing part split, part packing, printing parameters, all of that. So, each machine is actually printing a single system, but if you're running it in parallel on 10 printers, it's probably about an hour of print time. And I'd say for each system, it's probably about 5 minutes of assembly time.
Olu, would love to hear a bit more from your perspective what Solideon is doing right now.
Yeah, can everyone hear me? Awesome. Well, hey guys, my name's Olu, founder and CEO of Solideon. What we're doing is revolutionizing the defense industrial base for Europe and its partners through taking off-the-shelf robots and turning them into fabricators that are fully autonomous. We do that, first of all, in our factory in Berkeley, California. We have a 20,000 square foot factory where we do products as a service there. And the next phase of our business is actually taking that technology and putting it into the field. So robotics that actually don't just print parts, but assemble them and fully deploy them autonomously in the field. So that's what we're doing. And going back to your point earlier, I think what's changed to allow this to happen was three key things. I think the first thing was the global pandemic. It really showed how weak the industrial base back home in America is. I was an early stage employee at Virgin Orbit, and I had the ability to go and build autonomous production lines for rocket engines. And I realized that rocket engines were great, but the other things, the simple things like structures, for example, or even piping, like all those simple parts were actually a pain to get during the pandemic. And so that was the first piece of what we realized. I think the second thing was obviously the war on Ukraine, and it showed that you don't just need a strong industrial base, you need to be able to adapt quickly, and that's what we don't have the ability to do now in the US. We have innovative companies like Divergent that have led that charge, but we realistically need 15 to 20 more spread across the world, generously. And I think the last thing too is this innovation stack where AI has become so popular, you can use it as a tool in manufacturing now, and it's good enough to actually be able to iterate on that. Couple that with the fact that we have advancements in robotics where you actually can pair those two things together, and you don't need companies having to raise $50 to $60 million to get to products quickly. You're able to do this for a fraction of the cost, and that's what we've been able to do over the last 2 years. So, yeah, hopefully that answers your question.
Anna, I want to talk a bit more about what you've been up to in Ukraine in a moment, but I think first, clearly the elephant in the room, I think this week has been the Trump administration and a lot of the comments about the U.S.'s relationship with Europe in terms of sort of its support of its defense industry. And I guess just to sort of set the scene briefly, what do you think is maybe Europe's biggest weakness right now when it comes to defense manufacturing? And then I would love to eventually get into, solutions to fixing that, but I would love your initial take, Anna.
I think that the biggest weakness for us, of course, is our geographical position and our neighbor. So you know that we managed to scale our defense industry manufacture a lot. And of course, we do this under the constant challenge from our enemy. So like a couple of days ago, we had a massive missile strike. So I contacted all the manufacturers who suffered from that, like how we as a ministry who is controlling all the defense industry manufacturing in Ukraine can help. And all of them told us, like, no worries. We will manage it. We will, no delays with production. So we really are good in adapting to any circumstances. And I think that actually full-scale invasion learned us how to scale fast, how to divide manufacture to different locations, because this is what enemy actually forces us to do. So we are very good in scaling, and we are also very good with new ideas, not just for production, but also when it comes for manufacturing. So some of our manufacturers managed to go from civilian direction to defense industry manufacture. They managed to adapt the CNC machine for different productions. So now we are in the circumstances when we have to use everything that we have for scaling our production. And of course, I think that we are brave, we have great industry, but we also really depend on our partners. And this is another task of our ministry, is to build great ties with our partners, countries' industry, to share the experience, not just about the production, because everyone knows that we are very good in unmanned system, but first experience that we can share how to use those unmanned system, and second is actually how you can scale fast with the less investment, because we don't have that much funding as our enemy, unfortunately.
And I know that you and I were speaking backstage about how much industrial capacity Ukraine has built over the last couple of years, and I guess would love to hear a bit more about how you guys have done that, and also I guess maybe how you think about how much of that is the government kind of pushing for that versus industrial partners, and how you think about the mix there.
So as you may know, like our production capabilities now are over $20 billion, and we started full-scale invasion with less than $1 billion of production capability inside of the country. And of course, enemy forced us to do scaling, and we have all people involved. I think that this is important to understand, and a lot of people went voluntarily to the front line, and the rest of people just wanted to contribute to the victory somehow. So we have a lot of civilian company who started to produce something. Like when we speak about all unmanned system, like naval drones, aerial drones, electronic warfare system, some new technologies, most of them are produced by people from civilian sector, mostly from IT sector. And also, I don't want like underrate that Ukraine used to be a very powerful industrial country in the like early 90s, and that was the strategy of our enemy to close a lot of plants, a lot of manufacturers. So we really meet our enemy in 2022 with a lot of closed manufacturers, and we produced like the very, very small amount. But we had a great base, we had a great brains and engineer who managed to scale it and to renew this industry very, very fast. I think that the government role is financing, of course, and support. Like we as a ministry provide a lot of support mechanism to local manufacturers, and also we work with our partners manufacturer for localizing and for creating joint ventures in Ukraine. So government is supporting the great efforts which are like provided from both like private sector and from government-owned companies. But private sector is growing very fast. If we speak about conventional weapons, before it was focused only in government hands, like only government-owned company produce conventional weapons. Now we have like over 500 companies producing also missiles, producing self-propelled howitzers, ammunition, etc. So the growing of private market is significant.
I'm curious what you think maybe is needed more to kind of take it to that next level. Is it venture capital funding? I know Kevin and Olu, you both have raised VC funding, so I'm assuming that you'll say yes. But or is it maybe more, corporates and governments getting involved? What do you kind of think is maybe that missing piece that needs to ramp up more to help increase capacity in Europe?
I really do believe that joint ventures with our partner countries company would do a lot because we have experience, and sometimes we speak with our partners in a different language, because normally defense industry is big, is slow, but with such a great technologies like Kevin just mentioned, for example, together I think that we could do something massive. Because we all understand that we all need to increase defense production right now with the fast solution, because we need to save the democracy, and democracy needs a defense, and defense means good weapons. So I think that partnership, joint ventures would do a lot, not just for Ukraine, but also for our partners.
And Kevin and Olu, would love to hear a bit more from you about kind of who your partners are. I know that you guys are working with some governments, with some primes, but how do you think about maybe what the government needs to be doing better to work with startups, or maybe how you're cultivating relationships with primes? And maybe Olu, you can start off, and then we'll head to Kevin.
Yeah, for us at Solideon, we're building things the length of this stage, so massive hardware. So when you think of the industries that need stuff like that, that's primarily the maritime industry at the moment when we're talking metal fabrication of 10 feet or larger. And so we are working with customers that supply the industrial base for the US Navy and some of the AUKUS partnerships there. So yeah, for us, that's where our main go-to-market focus is really. Casting houses, for example, in the US, they have 20, 30-month lead time items for very expensive products that need to be manufactured quickly. And so for us, our whole thing is providing capacity so that we could win and help our country and our allies win in that state there. So for us, I think one of the things that we've learned, for example, with working with the Navy, is that things are traditionally slow. Companies could die quite literally by the time that they get awarded contracts. So the way you do that, and I think the way that you fix that is, one, you have to have a really clever business model to help you survive. I don't know that defense only is the only path for some of these advanced manufacturing companies to be able to take to survive, and so we'd certainly want the dual path route, and the reason for that is, for what I just mentioned. But so I think there's a relationship on being clever in a business model that is able to sustain yourself through those long sales cycles. I think the other thing too is actually, hopefully for startups, you're building something that your customers want. I think we take that for granted when we build companies, right? We think raising venture dollars is the end-all be-all, and I think people move quick when you have something that they want, and that's the reality. So we've focused on trying to do that. I think one of the ways that we've done that super quick, if I can talk about it, is basically building an operating system that allows you to be able to go do what we're doing in our factory on any 6-DoF robot arm. That's a huge time savings, but also integration savings, where lots of customers can do exactly what we're doing with really a software edit onto an operating system for robotics. And so I think, once again, clever business models to be able to help you survive long sales cycles is huge if you're a smaller company. If you have all the money in the world and you're starting with, tens of millions of revenue, it's a different story. But if you're building something, truly from scratch, you build your way up to that through something like what we just talked about. So, yeah.
Kevin, what about you?
Well, I mean, if we're looking at the U.S., obviously we're a sub to, I'd say, almost every single major U.S. prime and non-traditional prime now. So usually we'll get, say, on a modular cruise missile system, they'll come to us with a set of requirements. Then we take over design authority, basically put those in a machine. They get generated, printed, assembled, and then go through testing. I mean, recently we've done that, from the start of engineering to successful flight testing within 3 months recently. I'd say when you're looking at those systems, people obviously are looking in kind of, I'd say, the frozen middle of the bureaucracy that exists out there. They're looking like, hey, what is this new manufacturing? So even if you have a massive amount of test data, because we've been validated by 6 major global car OEMs, you still have people at that mid-level going, okay, how do we look at this from a casting standpoint when what we're doing is actually far superior to casting in terms of distribution of defects, voids, all of those things. So I think right now, the biggest barrier to very rapid adoption is that. I mean, our model right now, we can provide 40% lower variable cost. I mean, we can price significantly under casting right now and generate a very good margin. The thing that could be done is just, and we're working with AFRL on it, is just take this process and validate the process. And I would just say, if I was a NATO country, I would look at what we're doing, look at the process, look at the actual rate that we're doing and the speed, and figure out how do I rapidly start to deploy this. And I'd say that is less a matter of capital, because frankly, I can raise the capital to scale the model I have, as long as I have a design, demand signal. As long as I have programs, I can scale factories. I'd say the government does help. We do have a congressional ad in the 2025 budget to set up a factory that's probably going to be near Tinker Air Force Base in Oklahoma to do sustainment. But the main thing is recognize what this actually is, whatever the processes you were, and that's maybe where, a country like Ukraine or other, countries, NATO countries can figure it out. How do you look at this as a process? Don't think about, not made here. Look at actual facts, look at data, validate the process, and then look at how you apply it. And I think that's the thing that really will move things forward. I think without it, we're going to get crushed. We've gone from, the US has gone from 25% global manufacturing market share, trending now to 11. China's gone from 7% in 2000, trending to 45%. That's more than all of us combined. And they have more advanced manufacturing, and they're spending hundreds of billions each year on it. We actually have systems and technologies today, and I'll just call it AI-based manufacturing. I don't care who does it. Look at what we're doing, look at what other people do, that can actually provide that leapfrog solution. And so I'd say that's what needs to happen.
I'm curious, Olu, I know you have, you guys work a little bit in Europe as well, and talking again about the Trump administration, I think, I'm wondering how you think about the way that the administration's sort of comments or attitudes towards Europe might kind of impact, companies or governments' manufacturing goals. Anna, maybe you can weigh in as well. I mean, how do you think this kind of weighs into supply chain risks and how Europe maybe needs to diversify its manufacturing base? I just would love to hear, I guess, maybe from you two, any thoughts. And Olu, maybe you want to start off.
Yeah, we'll start off by saying we have strong investment from Europe. So it's a place that I feel responsibility when we took people's capital, that we would not just go and make an awesome company in the US, but we would try to be a force for good in ways that we can do so responsibly. And so while we have a great relationship with this administration right now in the US, and they've been helpful for some of the programs that we've gotten on as a business, I think the responsibility of European capital demands that we can't just clean our hands and say, it's not our fight, quite frankly. A strong industrial base in Europe equals one back home in the US as well. And I see that truly. And so the ways that we look through it, I think, are not saying that we have to build one mega factory in the US and every part or program goes through us. I think it's going through some of our customers that we have here in Europe and saying, how can we turn existing technology to do exactly what we do in California? And I think that's how we leave a lasting mark on the industrial base here. It's kind of like what Anna was talking about, right? Where we talked through, where she was talking through having to distribute your manufacturing. The only way you can do that is not to provide more suppliers, but more robust supply chains and manufacturing partnerships. And so that's what we focused on. If we don't have all the capital in the world to go and build 80 to 100 factories, let's go arm the people that already have factories and allow them to go and reindustrialize Europe. But once again, a strong European industrial base equals one for the world, and that's my views, particularly as a company. So, yep.
Anna, anything to add?
I'd like to add that as I'm responsible for manufacturing for industry only, in our case, it's not about government. Government changed a lot, and the defense industry lasts much, much longer. So today, we have a lot great partnership with American companies, with US companies, where we can learn a lot about from. We visited a lot of manufacturers in US. We invited a lot of US manufacturers to Ukraine also to share our experience. So I think that existing partnership will last for much longer than current administration and the next. So we as a ministry, we try to do industrial cooperation, we do business, so new administration maybe will change some political vector, but when it comes to business, to industrial cooperation, I think that we already have a great project that will only develop. And I don't think that it will influence somehow on the, our subcontractors that we have in US or some components cooperation, because of course we built our components base in Ukraine because this is part of our security. We also understand that in many cases we really depend on Chinese markets. They are very good in scaling and cheap production, but we also understand that this is not just Ukrainian security to have a great components base, but this is also how we can support our partners from Europe or from US when we have a great developed component base in Ukraine.
I think we're about out of time, but thank you all so much for joining us this afternoon.